Welcome to today's lesson on our new chapter, which is all about linear equations. And you can see here that the first concept we're going to talk about is slope. So at the top of the page, you see the question, what is slope? We have a couple different ways that we will talk about and use slope throughout the rest of the year, and I will tell you it's a concept that will continue to be used for the next several weeks and beyond. So slope is the constant rate of change between points on a line. It essentially is a ratio, and you probably have heard these two words before, of the rise to the run of a line. We use the letter M to represent slope. So we have four different types of slope. In these pictures here, you can see the four different types of lines that are represented with this little penguin on his skis. So a line that rises from left to right. So I'm going to make a little note here at the top. Rising from left to right has a positive slope. So a line that rises from left to right has a positive slope. A line that falls from left to right has a negative slope. A line that is horizontal. So a line that is horizontal going from left to right actually has a slope of 0. And a vertical line has a slope that we call undefined. Now, the reason that this is, if you think of the slope as a rise over run ratio, you will notice that a horizontal line has 0 rise, but it does have run. It goes on and on from left to right. So 0 divided by any number would equal 0. However, a vertical line has no run, but it has a lot of rise. So if we say there is a number that would represent the rise divided by 0 that would represent the run, this is not allowed. You cannot divide a number by 0, and therefore the slope of a vertical line will always be undefined. So you'll notice on today's handout, we are only focusing on finding the slope when we are given a graph. And the easiest way to do this is to count the rise over run, the vertical change divided by the horizontal change. So the vertical change in our point, we will start at the point on the left and move to the point on the right. So you will see that points have been given here. I will highlight those points in red. And basically, we want to count. We want to count how many units it takes to go up to get to this point. If I do that, I get 1, 2, 3, 4, 5, 6, 7. So I will say M equals, the top number is 7. And then I want to count how many units it takes to go to the right. That would be 1, 2, 3, 4. So the slope of this line would be 7/4. That cannot be reduced, so that would be my final answer for the slope of this line. Now our slope for number 2, again, we have a point all the way in the top corner and a point down here on the right. We go down for this line, so since we have to go down to get to the next point, that will indicate to us that our slope is going to be negative. We went down 3 units, so that is -3. And then we went to the right, and if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, I get -3/9. Now that is a fraction that can be reduced. 3 and 9 are both divisible by 3, so we would keep this as a -1 third once my answer was reduced. Now number 3, you should take notice this is a horizontal line. We've already established that the slope of any horizontal line is 0. Even if I was counting the rise over run here, it would be a rise of 0, a run of 1, and 0 divided by 1 would still be equivalent to 0. Moving on to number 4. Again, for number 4, this is a vertical line. So you'll notice that between the 2 points that are given here on the line, we have a rise of 3. However, we do not go left or right at all. So 3 divided by 0 is that case that gives you an error, not allowed to divide by 0. So our result, we write the word undefined. And you do actually have to write this word as the slope of a vertical line. We can't leave it as 3 over 0. I want you to know that that is undefined, and that's what we represent the slope as. For question number 5 here, we will count from the point on the left to the point on the right. Again, we're going to count our rise. We go up 1, 2, 3, 4, 5, and we go to the right 1, 2, 3. So our slope of this line would be 5 over 3, or 5/3. You should also notice that I am always writing the slope as a fraction. For each one of these, the slope should remain as a fraction unless it can be divided out into a whole number. I never want to see the slope written as a decimal in these cases where we're counting slope from a graph. Now, number 6, you'll notice that we have, again, rise over run. We count from the left point to the right point. We went up 2, and we went to the right 2. Well, hopefully we know that 2 divided by 2 equals 1, so the final answer for our slope for number 6 would be a positive 1. All right, that should complete the first page. So moving on to the back, looking at a few more of these questions, if I look at question number 7, I have a slope that is falling from left to right, which should indicate to us the slope is going to be negative. So we went down 3 and to the right 1. Negative 3 divided by 1 would be negative 3 for the slope on number 7. For number 8, we have a line that is rising from left to right, which would mean that our answer should be positive. We are going up 1, 2, 3, 4 blocks. So again, the rise here on number 8 we counted was a positive 4, and the run 1, 2, 3, 4, 5 is a positive 5. So the slope for number 8 would be 4/5. Number 9 we should see right away is a horizontal line. The slope is 0. Number 10, as we are counting, again, rise over run, we count up 4 and to the right 2. So 4 divided by 2 would give you a positive 2 for the slope for number 10. Number 11, we are going up 1 and to the right 3. So our slope for number 11 would be a positive 1/3. And number 12 is a vertical line, so we should automatically remember that the slope of this is undefined. Okay. One more row, and then I'm going to leave the rest for you to work on your own. So for number 13, we will count again. We went up 1, 2, 3, 4, to the right 1. So 4 over 1 would give us a result of a positive 4. For number 14, we will count our slope here. We went up 2, to the right 3. That is a fraction that can't be reduced, so our slope would be 2/3. For number 15, we have from point to point, we are going down from left to right. So since we are going down, our slope will be a negative number. And I count down 1, 2, 3, 4, 5 units, and to the right 1. So negative 5 divided by 1 is negative 5. Okay, so I am hoping that based on that lesson so far, you have an understanding of how to count to find the slope. I would like you to then complete questions 16 through 21 by counting the rise over run from the left point to the right point to get the proper answers for 16 to 21 slope values. If you have any questions, let me know. We will talk more about slope the rest of this week.